If we're watching this video, chances are we didn't do so well on the Unit 6 test. So what I'm going to do is I got version E right here. And all these versions, they have 10 questions. They're all very similar. I chose different compounds, different numbers. And I'm going to work through each one of these and explain it as I go. I have next to me a scientific calculator. I have a periodic table to find my molar masses. And for my conversions, I even have my mole roadmap to help me out when I need it. So looking directly at question 1, how many atoms are in 1 mole? So that's just a definition. 1 mole of anything is always going to equal 6.02 times 10 to the 23rd. For question number 2, find the molar mass of sulfur. So I'm going to need my periodic table for this. So I got to find sulfur on my periodic table. It's going to be right here. And this number right below the name, 32.066, that's the mass of 1 mole. That's our molar mass of sulfur. So I'm going to just round it to 32 grams per mole. So that's how much 1 mole of sulfur weighs. For question 3, it says find the molar mass of SO2. So this is very similar to that last question, but now I got multiple atoms in my compound. So I got to find, I got S here, and if there's no subscript, that means I have 1. So I got 1 S, and for oxygen, I have 2 of them. So we have to imagine just all the weight of all 3 of those atoms together. And I know my sulfur has a mass of 32 grams per 1 mole. So that 1 would equal 32. And oxygen, I got to find that molar mass. So oxygen's right here, 15.999. That's about 16. So if 1 oxygen weighs 16 grams, then 2 would weigh 2 times as much. So that would be also 32. My last step here is I need to add these together. And when I add 32 plus 32, I will get 64 grams per mole. So now as I move into question number 4, it's asking me how many grams are in 2 moles of SO2. So I'm going to start off, writing out the number they give me. That's always what I start with, 2 moles SO2, and I'm trying to get to grams. So if I forgot my conversions, I can always get my roadmap out. I'm starting at moles, right in the middle, and I'm trying to get to grams. So I'm going to have to set up a conversion factor like this, and that's going to be multiplication. So 1 mole on bottom, the molar mass on top. And I already found the molar mass of SO2 because that's the same as in the last question. So my molar mass is 64 grams. So 64 grams of SO2 is 1 mole. So now this is going to be a multiplication problem because the 64 is on top of my fraction. So it's going to be 2 moles times 64 grams per mole equals, plug this in the calculator, 2 times 64, 128 grams of SO2. This next question is also a conversion question. So how many moles are in 16 grams of SO2? So again, whatever number we're given, we start out with that 16 grams SO2, and I'm trying to go to moles. So let's take a look at what conversion we have to do. So again, starting at grams, going to moles, we got to use our molar mass, and here's our conversion factor this time. So 1 mole on top, because that's what we're trying to get to. And our molar mass was 64 grams. important to take note that in our conversion factor right here, 1 mole is equal to 64 grams of SO2. That's why I can do this. So now, as I go through, it's 16 grams, and I'm going to divide it by 64. And a good practice here is we could think if we have 16 grams, it's going to be less than a mole because 64 grams is 1 mole. So we got less than 64 grams. So let's plug this in the calculator. 16 divided by 64 equals 0.25 moles. Of SO2. All right, this next one, I got to find a molar mass of NaHCO3. So it's just the same thing as question 3 here. So I am going to find, see if I get, I'm going to have to write this one pretty small. I got 1 sodium and 1 hydrogen. Maybe I'll have to write it in 2 rows. And I have 1 carbon and I have 3 oxygen. And now I have to look at the periodic table to see how much each of those weighs. So sodium is a metal, so it's going to be way on the left side here. It's an alkali metal. So it is 23 grams per mole. So if I have 1 of them, it's going to be 23. And hydrogen, I have 1 hydrogen. It's on the top left here. 1 hydrogen would weigh 1 gram. Carbon, I got 1, and we can find carbon right up top here. That would be about 12 grams. And oxygen, we've done oxygen before, but let's review how to find it. Right there, 15.99, about 16. So 1 oxygen weighs 16 grams. So 3 oxygen would weigh 3 times 16, 48 grams. And my last step, I just have to add the mass of each of these together. So 23 plus 1 plus 12 plus 48 equals, let's see, 23 plus 1 plus 12 plus 48 equals 84. So that's going to be my answer, 84 grams per mole. And we're going to end up using this number in the next couple questions. So here we're doing a 2-step conversion. So how many molecules of NaHCO3 are in 126 grams of NaHCO3? So again, always write down the number we start with. 126 grams NaHCO3. Yeah, let's get that conversion map out here. 126 grams. My first step, well, we have to get all the way to molecules here, so don't think of it as one big step. Let's just jump up to moles. So to get to moles, I got to divide by my molar mass. So I got 1 mole. My molar mass, we just calculated that. 1 mole is equal to 84 grams. So let's plug that in our calculator. 126. This is going to be divided by 84 because the 84 is on bottom. And we got 1.5. And that 1.5, the units there are moles of NaHCO3. So now we got moles. So I just got one more step to get to molecules. I have to multiply by Avogadro's number. So this is what it's going to look like. 6.02 times 10 to the 23 molecules over 1 mole. So I take 1.5, which I have in my calculator already, and multiply by Avogadro's number. So times 6.02, shift log gives us that 10, 23, and that is our answer. 9.03 times 10 to the 23 equals, we'll write the answer right down here. 9.03 times 10 to the 23 molecules of NaHCO3. This next question, how many grams of NaHCO3 are in 4.5 times 10 to the 23 molecules? So here we are starting, we'll write the number down and then we'll take a look at the map. 4.5 times 10 to the 23 molecules of NaHCO3. And we're trying to get to grams, so quick zoom out here. We're gonna have to go to moles by dividing by Avogadro's number, and then we'll have to multiply by our molar mass. So we're trying to hit moles first. That's our first pit stop. So 1 mole is equal to 6.02 times 10 to the 23. This is going to be a division problem. And it's important to know which number we put in first. We always put the number we're given first. So 4.5 shift log 23. We're going to divide it by Avogadro's number. So divide it by 6.02 shift log 23 equals, and we have 0.747. We could round that to about 0.75, and our units here are moles of NaHCO3. So our last step to go from moles to mass is multiply by our molar mass. And we know that 1 mole of NaHCO3 is equal to 84 grams, because we calculated that already way up there. So we could plug this in our calculator. 0.75 times 84 is equal to about 63 grams. 63 grams NaHCO3. So I think most students find those last two questions, 7 and 8, probably the most difficult. On the back, we got a couple more questions to go over. Percent composition. The first step on any percent composition question is finding the molar mass of this compound here. So we know we got carbon, we have hydrogen and oxygen. In this case, we have 3 carbon, 8 hydrogen, and 2 oxygen. And to find the molar mass, we have to find the mass of each one of these. So carbon has a mass of 12 grams. So if 1 had the mass of 12 grams, then 3 would have the mass of 3 times 12, or 36 grams. Hydrogen, looking way up here, 1. So if 1 weighed 1 gram, 8 would have to weigh 8 grams. And oxygen, let's take a look. Review, we got 15.999. We'll call that 1 oxygen would weigh 16 grams. So 2 would weigh 32. And our molar mass is if we add all of these up. So we'll do that real quick here on the side. 36 plus 8 plus 32 equals about 76. 76. So I want us to think about each of these numbers here as our mass contribution. So if the whole molecule weighed 76 grams, 36 of those grams comes from carbon, 8 come from hydrogen, and 32 come from oxygen. So now I can use these numbers to find my percent composition of each. So for carbon, all I would do is I would take that 36, divide by 76 times 100%. And that would be my percent composition of carbon. So let me plug that in real quick. 36 divided by 76 times 100 is right about 47.4%, we'll call it 47.4% carbon. So we just got to do that with the other two elements now. For hydrogen, it's going to be a little bit smaller because it's only 8 divided by 76 times 100%. 8 divided by 76 times 100 would be about 10.5. 10.5% hydrogen. And we got one more to do. The oxygen would be 32 over 76 times 100%. And we get about 42.1%. 42.1% oxygen. And you could always double check if you are right, because all of these numbers should add up to 100% or really close if we rounded. All right, we got one last question. These ones are long, but we got the steps, step by step, we can work through it, and it's not too hard. So we got to first find the empirical formula, and then from the empirical formula, we could then find our molecular formula. So we're looking for the empirical formula of a substance with a composition of these percentages and a molar mass of that. We'll use that later. So the first thing we do is we take these percentages and we turn them directly into grams. So for carbon, 47.4 grams of carbon. Hydrogen, 10.5 grams of hydrogen. And for oxygen, 42.1 grams of oxygen. And our goal to get formulas, we need to change these grams into moles. So whenever you want to change grams to moles, we have to divide by the molar mass. And of each element specifically. So for carbon, and it would be 12, but for these questions, we want to be as specific as possible. So we'll go to the 100th spot. So we're going to use 12.01. For hydrogen, we're going to use 1.01 because that's what it would be if we rounded it. 1.01. And for oxygen, 15.999, we could round that just to 16. All right, so we're going to divide all of these, and we'll write the answers right below it. 47.4 divided by 12.01. Oops. 47.4 divided by 12.01 would give us about, and we want to keep a lot of decimals here, so 3.947, we'll say. 3.947. And this is moles now. We're now in moles. So for hydrogen, 10.5 divided by 1.01, we're going to get 10.396 moles of hydrogen. 10.396 moles of hydrogen. And for oxygen, 42.1 divided by 16, 2.631. So we could be done with the empirical formula if all of these are whole numbers, but they're not. So what we have to do from here is divide by our smallest number, because if we do that, it'll equal 1. And it's our first trick to get whole numbers. So we have to treat them all the same. Our smallest number is 2.631. So if you divide that by itself, it gives you 1 mole of oxygen. And we'll divide the hydrogen by that, so 2.631. And let's see what we get. Hopefully a whole number. 10.396 divided by 2.631. And this is the first step where we could start rounding. 3.95. And we're going to call that about 4. And lastly, over here, 2.631. 3.947 divided by 2.631, 1.5. Okay, so we're almost at whole numbers, but not quite. Over here, we got a 1.5. So the way we're going to approach this, and you might not have to if you got all whole numbers here, we got to multiply these by the lowest possible number to make them all whole. So for us, it'd be 2 moles of oxygen. 4 times 2 is 8 moles of hydrogen. And this is the whole reason we had to multiply it by 2, because 1.5 times 2 gives us a whole number now. So 3 moles of carbon. So our empirical formula, let me scoot this up here. After all that work, we're at our empirical formula. Empirical formula is equal to C3H8O2. All right. We should feel good about that. All right. Next step, we have to find the molar mass of that. So we're going to jump over here, and we got 3 carbon. And I'm going to kind of go through this a little bit faster because we should be pretty good at finding molar mass at this point. So if we had 3 carbon, they each weigh 12 grams, that would be 36 grams. Hydrogen, they each weigh 1, so we have 8, so that would be 8 grams. And oxygen, each weighs 16, so that would be 2 times 16 is 32. And if we add that all together, we should get 76 grams per mole. So here's where we are now. We know our empirical formula, and we know how much it weighs. So the next thing I want us thinking about is looking back at the question. We know the molar mass of our molecule, 228 grams per mole. So our next step, we are going to take the 228 grams per mole and divide it by this number right here, the molar mass of our empirical formula. And if we do that, 228 divided by 76, we should get a nice whole number, and we do here. Perfect. 3. That tells us that our molecular formula is exactly 3 times bigger than this. Excuse me. So I'm going to multiply this by 3, straight from what I got here. So instead of 3 carbon, we're going to have 3 times 3 is 9. Instead of 8 hydrogen, 8 times 3, it's a big number, 24. And instead of 2 oxygen, 2 times 3 is 6. And this would be the molecular formula. And that is it. So I'm hoping by watching these questions, it's made working through these questions a little easier. These are important, especially molar mass and mole mass conversions. So hopefully after a little bit of practice, we can retake that test and do a little bit better.